This video will introduce you to the scientific revolution. You all know about the scientific method from your science classes and probably take it for granted that in order to prove something scientifically, you need to be able to develop a theory, make a prediction, test it through experimentation, and observe and reproduce your results. But in the 16th century, this was a revolutionary approach. How did people in the Middle Ages know what to believe? They relied on the Bible and their religious leaders. Faith, tradition, and superstition shaped their belief system. This all changed with the scientific revolution. These changes were brought about by a new way of thinking that began in the Renaissance. Remember, during the Renaissance, philosophers, artists, and even clergymen began to challenge religious and traditional authority. These questions and challenges culminated in this period when the new scientists began to study the world using observation, experimentation, and reason, what becomes the scientific method.
These changes didn't happen overnight. They can be traced to the 16th and 17th centuries, specifically between the death of Copernicus in 1543 and the publication of Isaac Newton's Principia in 1687. Their ideas revolutionized the way people understood the universe. The popular understanding of the universe before the scientific revolution was based on the theories of Aristotle and Ptolemy.
According to Aristotle, the Earth was at the center of the universe. This is what we mean by the geocentric model. Geo means Earth, centric means center. The planets are embedded in crystalline spheres and rotate slowly around the Earth in perfectly circular orbits.
Ptolemy added epicycles, or mini-orbits, to explain things that Aristotle's system could not. It was a very complicated system.
Although they lived well before Christianity, their ideas were embraced by the Church because they supported the biblical account of creation. When God creates the sun and moon to give light upon the earth, the implication is that the earth was the center of creation and the sun and moon were placed in the heavens to serve it. In the 10th chapter of the book of Joshua, the Israelites were victorious because the sun stood still and the moon stayed. The implication here is that normally the sun does not sit still, but rather orbits the earth. Only God's miracle allowed this to happen. Note how these verses support geocentrism. The earth is in the center and is stationary, and the sun rotates around it. So this system was very entrenched in the medieval mindset, and it was not easily overturned.
The man credited with the shift to a heliocentric model is Nicholas Copernicus. Copernicus was a Polish priest who studied humanism and proposed a new model that placed the sun, Helios, in the center of the universe and had the planets, including the Earth, rotating around it. This shift was so significant that it is often known as the Copernican Revolution. As you can see from this model, Copernicus still maintains perfect circular orbits. This perfection was associated with godliness. Nevertheless, his heliocentric view was so controversial that Copernicus was afraid to publish it during his lifetime and only does so right before his death. Why was this idea so controversial? To suggest that the Earth and the rest of the planets rotated around the sun was considered blasphemy. It's no wonder that he waited until the end of his life to publish his ideas. Later astronomers, such as Tycho Brahe and Johannes Kepler, continued to study the heavens. Based on Brahe's careful observation of the stars, his student, Kepler, proposed the 3 laws of planetary motion that more accurately and elegantly explained how the planets moved. The first law states that the planets move in elliptical or oval orbits, not circular ones. This was the final blow to the Ptolemaic model and the traditional understanding of the universe. This brings us to Galileo Galilei, probably a figure you have heard of, who is associated with the heliocentric theory.
Although Copernicus had already proposed heliocentrism, he came to this theory through mathematical reasoning. He had no visual observations to back it up. When Galileo heard about the invention of the telescope, he built himself one and began observing the heavens. He observed sunspots. He saw moons around Jupiter, rings around Saturn, and was able to track the movement of different stars over the course of a few days. Through these observations, Galileo confirmed the heliocentric theory as well as the imperfection of the universe, challenging the Church's vision of a perfect, divine heavens. Unlike Copernicus, Galileo was willing to publish his discoveries during his lifetime for a more general audience. This angered the Church, who put him on trial in 1633 and forced him to recant or deny his views. Legend has it that he muttered, "But it still moves," referring to the earth as he left the courtroom. He spent the rest of his life under house arrest.
This brings us to the figure who marks the end of the scientific revolution, Sir Isaac Newton. Newton was a professor at Cambridge and is quite possibly the greatest scientist who ever lived. He was born the day Galileo died. Newton proposed that the natural world operates according to mathematical laws that are rational, understandable, and predictable. The laws that operate on Earth also operate in the heavens. If we can understand how gravity causes an apple to fall from a tree, we can also understand gravity's pull on the planets. Newton picked up the story where Copernicus and Galileo left off. Copernicus was able to describe the heliocentric universe. Galileo was able to give further support for Copernicus. Through his telescope, he was able to prove, through observation, that the Earth and other planets orbit around the sun. Newton came along and explained how the planets moved through his laws of gravity. For more information about Newton's laws of gravity, please consult your local physics teacher.